Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the Roman numerals exercise from the Exorcism.io Ruby track. So what we need to do in this exercise is take a number and convert it to Roman numerals. So I think it'll be kind of clear how this works as I go in there. The Romans, but their description here, the Romans wrote numbers using letters, I being a single digit, I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. And so they show an example here so here for 7, what you do is you take 5, V, and add 2 ones, right? So that means that equals 7. And they say that we don't really need to go higher than about 3,000. And the reason for that is, I think, well, first, the Romans didn't tend to do that, but also because the way that these Roman numerals work, and we don't have a way of expressing 5,000, because what they did was they would write the V and write a line over it. So that's not going to be easy for us to express here. So if we don't have to go above 3,000, which 3,000 would be MMM, and get anywhere close to 5,000, then that'll be much easier job for us. So here's some examples they have. So 1990 is MC or MCMXC, and so the way this works is M is 1,000. CM is, if you'll notice, M is 1,000, C is 100. So by putting it here, prepending C to the M, that's 900. See, 900 CM. It's 100 less than 1,000. And then XC is 90. It's 10 less than 100. 2008 is written as MMVIII. So see, that's 2008. 2000 followed by 8. Okay, cool. If you want, there is more information here about how Roman numerals work if you want to go look at that. But I'm just going to go ahead and grab this and get down to it. Let's pull down the exercise. I'm going to enter that and start a new TMUX session. Let me go ahead and open up my tests and see what we have here. Okay, so our job is to take integer and to add a to_Roman method, an instance method to integer. All right, let's see. So I'm going to go ahead and open my testing pane, and then let's copy in our rake file. And then go ahead and run our tests. And they're going to fail, of course, because I deleted my Roman numerals file. So let me go ahead and create it. And now it's going to fail because there's no to Roman numeral method on integer. So we're going to solve that. Let's go ahead and swap these panes and open up the integer class and define to_Roman. And now it's going to fail because we're not returning anything. So it expects us to, we're not returning anything. So let's go ahead and just hard code our return value to begin with. All right, cool. And then we'll implement our next test, which will now force us to start implementing some functionality here. Okay, cool. So we're returning 1. We need to be able to return 2 for 2. So what I'm going to start doing here, because I think the way we're going to be able to do this is to build a mapping from digits to Roman numerals. So if we look at one of the examples that they gave us here, we have 2008, and that is expressed as MMVII. And then if we look at 1990, that is expressed as MCMXC. Let's see if there was another. Let me give another example so you can see. Oh, sorry, I left an I off of here for 8. So let's see, what would 1998 look like? Well, it would look like MCM XCVIII. So what I want you to notice here is that the ones digit will always look like the ones digit. It doesn't change regardless of other things. But also the tens digit will always look like the tens digit. Same with the hundreds digit, same with the thousands digit. So we can build up a set of mappings for ones, the ones digit, the tens digit, the hundreds digit, and the thousands digit, and simply translate those if we have anything for them in our number. So here, what I can do is I can just start building out. Let me call it ones. Let's call it ones for now, and I might have to change that later. So ones equals. Yeah, I built a new keyboard and it's got fewer keys, but it has layers. So I've changed things around a little bit. So you may have noticed if you watched the previous video, me fumbling a little bit with certain things that I haven't fumbled with before. I'm still fumbling. I'm kind of learning. My fingers are learning their way around the layout that I have here. So in this case, I've got ones, and ones will equal, or 1 will equal 1, and I've got 2, right? So 2 in this case will equal 2. And so if I simply return ones self, so I'm just going to look up myself in ones. Right now, well, this one, yes, this will work just as is for right now for these two cases. See, we can start building up what this needs to look like. 3 is going to fail because we don't have 3 in our hash yet. Well, let's go ahead and add it. Okay. And next example 4. We'll just keep going down the line and doing the same thing. It's going to fail because it's not in our example yet, or it's not in our hash yet. 4 is going to be IV. And this will work now. 5, same thing. It's going to fail. So let's add it. You see, are they going to take us all the way up? If not, we'll have to just fill out the rest. But yeah, they are still here. 6 is going to fail because we don't have it in our mappings. So let's go ahead and add it. 6 is going to be, so you see how this is working? 5 is V, so it's going to be V plus 1, right? VI. And then, okay, they skip all the way to 9. We can do that, and then we'll fill in 7 and 8 because we want it to be complete, even though the tests, you know, I could go back and add tests for 7 and 8, but I think I'll be happy just filling in the gaps. So of course, yeah, that failed because we don't have 9. So let me add it. And 9 is going to be 1 less than 10. So you see how this works? 4. It's you get up to 3 straight lines and then, or 3 i's, and then it's 4 because it's 1 less than 10. Same here. We'll get up to 3 i's except for 7 and 8, and then it's 1 less than 10. Okay. So I'm just going to fill this out and add these guys. That's not going to break anything, but there's not explicitly a test for that. And so I'm guessing this is going to break down here on the next one. Yeah, because we're jumping up to 2-digit numbers with 20. So this will fail. And I'm going to have to do something else. So I'm actually going to I'm going to recomment this, or reskip this test so that I can refactor from green to green. So really what I'm going to wind up here is I'm going to have ones, I'm going to have tens, I'm going to have hundreds, and I'm going to have thousands that look just like this. And what I can do is I can take self. I think I'm going to need to rename this because what I want to get is the digits that occupy that place. So let me call this ones. Let's see, what should I call this? Ones Roman, maybe. And let me get ones from self. And the way I'm going to do that is I'm going to do self 1. So let's see, ones is self modulo 10, not 19, 10. And what this is going to do is it's going to give me the remainder of dividing it by 10, which should give me this. So this should, let's see, this should work. All my existing examples should work here. And what I'm going to do is I'm going to put this in an interpolated string. Which should still work because it's just that. And to get my next example, I'm going to have to do the same thing for tens. So let me go ahead and, so I've got to get 22 is what I need. So I'm going to come here. Let's skip this. Actually, let's not skip it yet because I want to refactor from green to green. And then I'll uncomment that test and it will hopefully work. So I want to copy this. And I'm going to do tens. I'm going to replace my X with the C. Let's just do that here. Whoops. To be 100. My V's I will replace with L because L is 50. I have 50 instead of 5. So let's substitute V for L. Okay. And then because I'm in tens instead of ones, the I's will be replaced with X's. X. Okay. And then I think it'll be a little bit more readable if I actually make these tens places here. It'll be a little bit clearer what's going on. So let's just do that. All right. And then what I want to do here is I want to get tens. So similarly to this, what I need to do is, or the simplest way I can think of to do this is to divide self by 10, and then take the modulo 10, and then because I need to be back in tens, I'm going to multiply that by 10. And I think the order of operations is going to work fine here. Anyway, and then what I need to do is I need to insert that here before, whoops. Haha, I did something wrong there. That's okay. I'll fix it here, because what I really need is not self here. I need ones. So this, theoretically, what'll happen in my single digit example is that there won't be an entry here for this, right? This is going to be 0. And so there's no entry for 0 in my tens Roman. And so this is just going to be nil. And I won't get anything there. And I'll just get my single digit. But let's test that theory here. All right, that works. And if I did this right, then when I comment out this skip and I test 20s being 2 x's and I can get 27 here, this should just work. All right, cool. So test 48 is not 50 and 2, but rather 40 and 8. Okay, I think this will work. Yep. 49 is not 40, 5, 4, but rather 50, 10, 10, 1. What is what? It is 49. Right there like that, and then 40, and then 9. Okay, and then 50 is a single L, so it should be 59 should be L I X. We got to comment that skip out. Cool. And then 90 is 110 is XC. So yes, this should work. All right, and then this will break now because we don't actually have 100 yet. All right, cool. So let's go ahead and implement it. I'm not going to comment that out now. I'm just going to do exactly what we just did for tens, and do it for hundreds. Again, for clarity, I'll go ahead and add another 0 here. And then I just need to do the same little dance. So instead of 100, C for 100, that's going to become M. L's will become D's for 500. So let's just change L to D. Then let's go ahead and change X because we're not dealing with tens anymore. We're dealing with hundreds. And C is 100, so we're going to change X's to C's. X for C. All right. And then I need to deal with it down here. I need to get hundreds. I'm going to do the same thing I did for tens. But instead of 10 here, I'm going to divide it. Whoops. I'm going to divide it by 100. Divided by 100, same thing. Take modulo 10 and then multiply it by 100 again to get it back in the right at the right order of magnitude here. And then I need to prepend hundreds here. Hundreds Roman with hundreds. And this should now work. If I did it correctly, this should work. All right, cool. Let's see how far this gets us. 60. Okay, we are so 163 should work. 402. 500. Wait. 500 and 575. 911. 911. Too much finger fumbling with this new keyboard. And then 1,024 will fail because I haven't done thousands yet. So let's run it. It's going to fail. And we just simply need to do the exact same dance for thousands. So let's just copy this guy. Thousands. Add a 0. Let's change this M. You know what? We're only going to go up to 3,000 because we don't have a character for 5 or 10,000. And so we simply need to change these C's to M's. That's all we need to do. C to M. Oh, come on. There we go. And then add it here. I see. I also need to capture it here. And again, we're going to divide by 1,000 and then multiply by 1,000. And then that should work. And the rest of our tests, I think, will work now. So 3,000 should return 3 MMM. And that's it. Yep. All right, good. Our tests are good. I'm going to go ahead and close the test running pane here. And maybe do a little bit of refactoring. So what I would like to do is pull these out into constants. So, okay, let me go ahead and pull it out here. And let's see, thousands. I'm going to rename it just to thousands. And then I need to come down here and rename it on line 50 to just thousands. That should just work. All right. I'm going to do the same here for hundreds. Let me hundreds. Come on. Do the same for tens. And then now do the same one more time. Whoops. For ones. And then one more thing I see here is I'm using other local variables here, and I'm going to refactor these by extracting methods for these. And in Ruby, I don't have to change anything about how I'm calling it here because I don't need parentheses in Ruby to call a method. So I'm gonna extract these to private methods down here at the bottom, starting with thousands. All right, that just works. Same with hundreds. Tens. And then finally, with ones, all right, I'll remove this extra line here. And I think we're good. That'll do it for this. Let me go ahead and submit it. And I'll see you in the next video.